So this video is going to be served for pretty much answering the questions on the do's and don'ts that you can do with tubing. So this is really important because we do get submittals of files where you just can't manufacture it the way that it necessarily is being designed, and I just want to cover that. So this is a good example of right here. This is a cope that is close to a bend. You could see here, I believe it's about 3/8 of an inch. So if I click there and here, I've got about 3/8 of an inch. It's just not enough room for the bender to grab it because we got to hold the front of this tube when we bend it around. So with that being said, I need to make sure that when I'm designing this stuff, I'm adding enough room to grab it. So people say like, well, what is that minimum distance there? If I'm going to measure from here to here, this is a lot better. I want to be about 2 inches from the deepest part of the cope, and that makes it so that we have enough material to grab onto so that when it does rotate and bend the tube, we're not ripping it out or cracking the tube. Another thing that we get a lot of issues with is we see a lot of features in the bend. So if I change this to like say 1/2 inch, you're going to see this cope ends up in the bend. We can't do that. Not only can SolidWorks not figure out how to straighten that tube out, but we physically can't bend that and have the notch. So what's going to end up happening is a lot of the time, if if it's just like you have to have it this way, then what we could do is we extend it out, 3 or 4 inches, and then we'll laser etch what we can of the cope, the part that's not in the bend, and then you would have to hand notch it. So like for example, let's pull this back out. Let's change this to 1.25 inches. So in this scenario, the cope is not in the bend, but we're too close. We don't have enough room here. So in order for this to be a successful bend, so we're gonna actually laser etch this, and then the tube will look like it's extending out. So let me show you what that would actually look like. So if this tube was here, we'd be asking you, hey, we can't manufacture that. But if you absolutely need it and it's part of your design, then it's going to become a hand notch tube. In some cases, for like a production setting, we can set up a fixture on a mill and we can get it to be a post process after the bending. But the whole key of a lot of this process to streamline it and to keep it cost effective is to cut the cope before we go and do the bend. So, for example, this is essentially what you're going to receive as a finished item. Even though you expect the cope to be there, it'll have to be removed so that we can actually have enough room to bend it. So moving on, we can't have any etch marks or cuts in the bend itself. SolidWorks cannot do anything with it. Not only that, but there's even scenarios where if something is etched in the bend, we've even seen tubes crack while bending just from the stress riser from the actual mark itself. So we can't have anything in the bend no matter what. So this is kind of another big one is, here's a radius roll going into a bend. We need to make sure we always have at least 4 inches between bends. So for example, I'm going to go ahead and increase this to 4 inches. Oops. That way, when I bend this, I now have a starting position for this next bend to happen. There are some scenarios where if you absolutely need a specific thing to happen, give us a call, send us an email, and I can sometimes in some tooling die scenarios we can shorten this up. But it's kind of a case by case scenario. But a good rule of thumb is always keep a 4 inch straight between your bends. So we have a bend here, we have a 4 inch straight, which is right here, and then we go into our radius, or let's say another bend. The next thing I want to cover is actually on the radiuses is that a lot of people get concerned about this straight section, and on a computer it's really relevant when you have this line here, but in real life when you're looking at it, you can't really tell where that radius is starting. So honestly, this'll look just as if it went from a bend right into a radius. This straight section really doesn't have an impact. Your eyes just kind of sink onto it from SolidWorks. So I wouldn't worry too much about these little straight sections, as you need to have somewhere that you can start and finish these bends. So another thing that is really important is that the tangency of these lines, we sometimes receive files where we don't have tangency. Like it'll look so close, this line might be kicked up at 0.0001 degrees, but that's enough to make it where it's not a true tube. So make sure all of your lines are tangent and that they're flowing accordingly. One thing to mention is like this radius right here. I believe it's a 150-inch radius. This is a good radius, but one thing to note is like if I went down to like a 30, like this super tight one, we can still roll this, but you're gonna lose a lot of accuracy because we're literally pushing the material through rollers. So it's a process that is almost like an art. So the tighter we go, the less accurate we're going to have. And we can get some good repeatability on it, but we come down to the point where if a material is tenths of a thou different, we're going to get different radiuses, or the temperature changes outside, we're going to get different radiuses. The other thing to note is if I go to like a really big radius, like sometimes we see like a 450 here, or something like that, something really big. So the problem with these radiuses is that there is a certain threshold that we need to bend the material for it to start bending. So like for example, to get this radius is really hard because you have to bend it to a certain point, roll it to a certain point to start taking the bend or the deformation in the tubing in order for it to happen. So like for example, the second we find that moment when it starts rolling, we're already past it. Maybe we ended up at like a, let's say a 300-inch radius right at the start. So I guess a good rule of thumb for this is to range anywhere from like a 75-inch would be like my tightest I would go on like a accuracy style roll for being tight. As big as I go would probably be about 300. Now you can do the other ones, but just note you're gonna have some. If you're outside that range, you're kind of getting into the thing where you're accepting the fact that hey, there's a lot of factors going into forming this tube, and there's a possibility that you may need to do some massage work on the rolling because it is not just like a die where we're forming it around the die. We're actually pushing it through rollers, so it's very hard to make sure that all of the variations are the same. So in this case, definitely make sure to do that. The other thing is right here we are not normal cut. So this is just cut as if it was cut with a saw or a saw, a hole saw. We need to make sure that this is normal cut, so we'll use our normalizing procedure. If you're unfamiliar with that, take a look at the normalizing section on the Learn page of our website. The other thing that's super critical, and we've covered this on our Learn page, is make sure your CLRs match our chart exactly. That's going to give you the most precise part you can get. That way, if you have copes landing on bends, or you have 90-degree or 180-degree bends landing somewhere, they are accurate, they are true to what you're going to get in real life. So make sure your CLRs are always correct. Other than that, that's kind of the overall concept. I can't stress enough, just make sure you do not put any etch marks or cut features in any of the bends or rolls, and then make sure you keep them away. So if you put let's say you put a key right here next to the bend, hey, we can use some logic and say like that's probably going to crack. There's a lot of stress there. So keep your keys as far away as you can. If you have a cope landing right here, put the key on this side. Don't put it, over here right on the edge, or obviously don't put it in the feature itself because we can't do it because it'll crack. Other than that, that's kind of the gist of it, and let us know if you have any questions. If you do have some sort of special process that is a little bit more difficult and needs some extra, doing, just let us know, and then we can take a look at it and see if there's a possible way to make it happen. So thank you.